Hello guys, let's look at this question. And first I read the question. Find dy over dx from first principles given that y is equals to sine x plus 1. So guys, we are required to differentiate sine x plus 1. And so guys, I do the question. So guys, we start from the equation of differentiation from first principle, and the equation is written as this: f(x) equals to limit as h tends to 0 fx plus h minus fx all over h, or we could still have fx, that is f prime x, equals to limit h tends to 0 f x plus h minus f x minus h all over 2h. So guys, having those two equations, I would choose to work with this second equation. And so we start off doing the question. So we shall have f prime sine x plus 1. This gives us limit as h tends to 0. We will have now x sine, sine x, then we add h plus 1 like that, minus sine. Using this equation, you now subtract h from x minus h plus 1 all over, this gives us 2h. And so guys, we continue. Guys, let me just leave this one behind. I'll write it later. So guys, this is now going to be equals to, before we come to that guys, there is this factor formula from trigonometry. And the factor formula guys says, let me just write here, factor formula. This one is written as this: sine theta minus sine phi. This one comes to, or is equals to, 2 cos theta plus phi all over 2. Then here we have sine theta minus phi all over 2. So guys, we have that equation. And so therefore guys, we are going to subject our equation here to this, because as you can see guys, we have sine theta minus sine phi. The same case, we have sine of a number minus sine of another angle. And so therefore guys, we use this formula to convert this to this format. And so therefore I will write this is now equal to limit. You have limit, that is f prime sine x plus 1 is equals to limit h tends to 0. I will write now, instead of writing this, I write 2. And now come and convert this into this form. So we shall have cos, shall write cos theta, which now is represented by x plus h plus 1. So I'll write x plus h plus 1. That is theta. For the phi, it's represented by x minus h plus 1. So it's going also to be plus x minus h plus 1 all over 2. So the 2 here is not this 2, but we can write the 2. So this is going to be all over 2, like that. Guys, also we have sine. Sine, we can maybe bring it here down here, so that now we have sine. Now we have our first, that is angle, which is x plus h plus 1, x plus h plus 1, and then we now minus this. So it will be minus. Because of this minus, the signs are going to change here. So you have minus x plus h and then minus 1, like that. This all over 2. And so therefore, guys, we can work out that this is now going to be equal to limit h tends to 0 2. We can work out this. This is going to be cos x plus, this is going to be cos x plus x, we have 2x. H minus h is 0. 1 plus 1 is 2. All that all over 2. Then you have sine x minus x, that is 0. H plus h, 2h. So we have 2h here. 1 minus 1 is 0. So we are left with 2 here. Like that. So guys, all that is now divided by, now we write all over 2h. So all this, guys, we are dividing that by 2h. And so therefore, guys, we are going to have, this is equals to limit h tends to 0, shall have cos. For cos, we can divide this 2 like that. So we are left with the cos, with the 2, cos x plus 1, sine, you can divide that 2 and that 2, h, all over, now 2h. Guys, we can cancel that 2 and this 2. So we are left with, this is equals to limit h tends to 0, cos x plus 1, sine h, all over h. Guys, from there, we also know that limit, we can say limit As h tends to 0, sine h all over h will now become 1. And so therefore, guys, we shall be left with limit as h tends to 0, we shall have now cos x plus 1, guys, as our solution. And so therefore, we can write now f prime sine x plus 1 is equals to limit h tends to 0 cos x plus 1. And so guys, that is our solution. Or we could still write dy all over dx. This one gives us cos x plus 1. So guys, thank you for listening to me. Bye bye.